Chemicals and chemical processes play a major part in our lives. From the cars we drive, to the food we eat, to the ways in which we relax. We depend on a vast array of chemicals to make life easier, safer, and more convenient. There is a very high chance your work brings you in contact with chemicals and chemical processes. For example, even washing your clothes with detergent brings you in contact with chemicals that can be harmful to your health. While chemicals available for use in our day to day lives can bring us a lot of benefits, chemicals can also be dangerous or even deadly. Corrosives, for example, are used in life saving pharmaceuticals. These same chemicals, however, can cause severe skin damage, blindness, and even death. As dangerous as chemicals are, you can handle them safely by knowing what you are working with, how to correctly handle it, and what to do in an emergency. This program will show you the best practices in chemicals management. When looking at the flow of chemicals inside a company, it is clear that chemicals are present from the moment it enters the gates of the company through to the point of disposal. Initially, exposure to chemicals can occur at the point of purchase and unloading. The chemicals are then moved to storage areas where they are kept until needed. Next, the chemicals are distributed throughout the company to be used in various processes. The application stage of the chemicals comes next, where the chemicals are used in various chemical processes, such as in the production lines. After application, the chemicals are collected and treated before finally being disposed in a safe and environmentally friendly manner. There are different degrees to which workers or employees can be exposed to chemicals throughout these stages. Correct chemicals management can be used to minimize the risk of exposure at all these stages appropriately. If chemicals are not managed properly, the company can incur costs in the following ways. First, we have direct costs. The company can suffer the loss of materials, be required to pay compensation for injury or illness associated with the chemical exposure, lawsuits and legal fines, as well as loss of product and orders. Next, we have the productivity cost. The company can lose valuable work time due to employees being injured or ill, loss of production time and efficiency due to the closure of production lines because of spills or accidents, and reduced product quality and compliance. Finally, there is the cost of trust in the company. The company will incur losses to the trust placed on them from stakeholders if the chemicals are mismanaged. For example, the loss of customers and worker trust, as well as the loss of trust from the community around the company caused due to environmental damages. One of the most important parts of chemicals management is the hierarchy of control. Controls are used in various degrees throughout the company to reduce the risks and consequences of hazards posed by chemicals. The first and most effective type of control in the hierarchy is the elimination or removal of hazards. For example, if employees must work high above the ground, the hazard can be eliminated by moving the piece they are working on onto the ground level to eliminate the need to work high up. After eliminating all possible hazards, see if substitutions can be made to reduce hazards. To be effective, the substitution must not produce another hazard. An example of substitution would be the use of larger particles instead of powders. If a hazard cannot be removed or substituted, and it is essential to the process, the hazard can be controlled by using engineering controls. This method does not eliminate the hazard, but rather isolates people from the hazard. For example, if a flammable chemical is used, it can be stored in an isolated storage area. The final two control measures are focused on the safety of employees by giving them awareness, guiding their actions, and protecting them from the hazard. Administrative controls are changes done to the way people work. Changing procedures, following guidelines, giving employees awareness and training on proper usage are a few examples of how administrative controls can be applied. The final control measure is the use of personal protective equipment to act as a last barrier between the chemical hazard and the employee or worker. The appropriate PPEs can be identified from the MSDS or safety data sheet and given to the workers accordingly. Through these control measures, hazards can be removed or reduced for a safer work environment. Chemical policies and procedures are the foundation of an effective chemicals management system. They need to be developed for each stage of the chemical life cycle, from purchasing to disposal. They should include legal and other requirements, responsible persons, and appropriate work practices and controls. An effective chemicals management system will have in place policies and procedures addressing the following: chemical procurement and purchasing. One part of chemicals management is being able to identify and eliminate hazardous chemicals at the beginning stages and preventing them from entering the gates of the company. Based on the company type and the chemicals used within, a specific purchasing policy should be developed. The development should include all related parties of the company, and the policy should be communicated clearly to the parties. Next, the chemicals used within the company should be in compliance with the applicable regulatory requirements of the country or the governing body. Chemicals should also comply with the list of restricted substances and avoid the use of such restricted substances. Hazard communication will be discussed in more detail further along in the presentation, along with safe storage, handling, use, and disposal of chemicals. As discussed in the previous slide, control systems and procedures to prevent worker and environmental exposure to chemicals should also be addressed. By considering hazard prevention solutions in addition to hazard control, it is possible to create more positive outcomes for the customers, workers, as well as the environment. Hazard communication is very important when considering worker awareness of chemicals and its danger. Workers should be able to identify and deal with chemicals in a safe manner, and various tools and guidelines can be used to assist with it. The chemical inventory, for example, is used to list out the hazardous material present in the company and can be a very important tool to communicate the hazards present by these chemicals. How to prepare this inventory will be discussed in the next slide. The chemicals present in the company should also be appropriately labeled to easily identify the materials and the potential hazards it might cause. More information about labels and the data that should be present on labels will be discussed further along in the presentation. Providing training to all employees about how to identify and work with hazardous materials is also an important part in hazard communication. The chemical inventory is a document that has information about the chemicals and the amount of chemicals present in the company. It should be readily available at all times in case of emergencies. The chemical inventory should include the following details. Firstly, chemical product name or code, supplier name, location and contact person, chemical ingredients name, CAS number and percentage of content, hazard identification, that is, flammable, corrosive, and others, process, storage, and use location, amount stored on site, usage quantity, that is, monthly, annually, the availability of globally harmonized system, GHS compliant SDS or associated SDS number, and finally, the revision date. It is also very important to keep this information up to date. Next, we shall look at the MSDS or Material Safety Data Sheet. Material Safety Data Sheet or MSDS and the Safety Data Sheet SDS are documents that list information related to occupational safety and health for the use of various substances and products. Safety data sheets are widely used systems for cataloging information on chemicals, chemical compounds, and chemical mixtures. This information may include instructions for the safe use and potential hazards associated with the particular material or product, along with spill handling procedures. It follows a 16-section format which we will go through now. 1. Identification and supplier. 2. Hazards identification. 3. Composition. 4. First aid measures. 5. Firefighting measures. 6. Accidental release measures. 7. Handling and storage. 8. Exposure controls, personal protection. 9. Physical and chemical properties. 10. Stability and reactivity. 12. Ecological information. 13. Disposal considerations. 14. Transport information. 15. Regulatory information. And finally, 16. Other information. If we consider this in broad strokes, Section 1 to 8 give general information about the chemical, ID, hazards, composition, safe handling practices, and emergency control measures. Next, Section 9 to 11 and 16 give details on the physical and chemical properties, stability and reactivity information, toxicology data, exposure control information, and other material including preparation date and last revision. Lastly, Section 12 to 15 are for consistency with GHS labeling. Of the above 16, let us take a closer look at sections that are more important for worker safety and health. Let us first discuss first aid measures. The purpose of first aid is to minimize injury and disability. This section in the MSDS gives a description of the recommended first aid measures in case an incident occurs where a worker, employee, or any other individual is exposed to the chemical. The four most common methods of exposure are through exposure to the eyes, skin exposure, inhalation, and ingestion. The MSDS provides first aid procedures to follow if a person is exposed in the previously stated methods. Firefighting measures can be found in Section 5 of the MSDS. This section describes fire and explosive properties, recommendations for preventing explosions and fires, as well as appropriate methods to extinguish the fire and the suitable and unsuitable media to be used. Technical information such as flashpoint, lower and upper explosive limit, extinguishing media, and personal protective equipment can also be found in this section. Let's look at fire classes and extinguisher types in more detail in the next slide. There are various fire classes and extinguisher types. The appropriate fire extinguisher must be used to fight the class of fire. For example, water fire extinguisher should only be used to fight Class A fires because it will be ineffective with other classes like electrical fires. By following this chart and having different types of fire extinguishers near areas that are at risk of fires, the damage to human life, property, and the environment can be reduced. Next, we shall talk about accidental releases and how to combat them. Chemical spills are likely to happen during transport, handling, and use if appropriate procedures are not followed. If a chemical spill does occur, the first thing that should be done is identifying the chemical and to wear the appropriate PPEs. Then the spill must be immediately contained to stop it from spreading before cleanup can be attempted. After cleanup of the chemical and the affected area, the chemical should be disposed of safely. The MSDS can be used to identify the appropriate actions to be taken during the spill. It is also recommended to have a spill kit easily accessible in case a spill occurs. The kit must include a barrier to contain the spill, such as clean dry sand or a commercial product, vermiculite to absorb the spill, reagents necessary for decontamination procedures such as calcium carbonate, personal protective equipment including protective clothing, chemically resistant gloves, safety glasses, appropriate containers in which to store waste and contaminated material such as plastic bags or buckets, and warning signs and barriers. It is also important to maintain these kits and be placed in easily accessible areas. If someone is not sure about appropriate handling and storage measures for chemicals, they can turn to Section 7 of the MSDS to get that information. In it, you can find appropriate storage temperatures, proper handling procedures to minimize accidental exposure and releases, and storage procedures. Next, we shall talk about safety features of bulk and production chemical storage areas. Firstly, the chemical storage areas need to be secured and sufficiently covered. Containers should be stored on impervious surfaces such as epoxy-treated surfaces. Secondary containment units should be in place. This secondary containment should be at least 110% of the volume of the largest container stored on or greater than 10% of the total volume of the stored substances. The area should be well ventilated. There should be easily accessible safety showers and eye wash stations nearby. These areas should be clearly marked as well, for example using signs to indicate their location. Restrictions should be placed on drinking, eating, and smoking. Spill kits should be easily accessible. Firefighting equipment such as fire hoses and fire extinguishers should be present. Signs indicating PPE required to be worn when working in the area should be posted in visible locations. Forklift routes should be clearly marked. And finally, incompatible materials should be segregated. This chemical compatibility chart can be used to identify which chemicals can be placed together and which chemicals need to be isolated. According to the colors of this chart, you can identify which chemicals should be placed where. Green indicates that the chemicals can be stored together. Yellow indicates that the chemicals should be separated by at least 3 meters. Orange indicates that the chemicals must be segregated by at least 5 meters. And red indicates that the chemicals should be isolated from each other. There are also some special cases where the information found in the MSDS should be taken into account before storage. For example, according to the chart, flammable gases can be stored with other flammable gases, but flammable liquids and flammable gases must be segregated by at least 5 meters. Similarly, one can use this chart as a guide when designing their storage areas. Next, we shall look at Hazardous Material Identification System. The Hazardous Material Identification System, or HMIS, is a numerical hazard rating system that incorporates the use of labels with color developed by the American Coating Association as a compliance aid for the OSHA Hazard Communication Standard. The colors present on the label can be used to identify the following. Blue indicates the health section, conveying the health hazards of the material. Red indicates the flammability section, conveying the fire hazards of the material. Yellow indicates the reactivity of the chemical. And finally, white represents personal protective equipment that should be worn when handling the material. The blue, red, and yellow parts contain a number which indicates the severity of the chemical, with 4 indicating that the chemical is very severe and 0 indicating that it poses no significant threat. When designing the label for chemicals, HMIS can be used to clearly indicate the characteristics of the chemical. It is important to provide training for the workers to understand the labeling as well. The Globally Harmonized System of Classification and Labeling of Chemicals, GHS, is an internationally agreed upon standard managed by the United Nations. It was set up to replace an assortment of hazardous material classification and labeling schemes previously used around the world. The elements present in the GHS standardized label are symbols conveying health, physical, and environmental hazard information assigned to the GHS hazard class and category. Single word, danger, or warning will be used to emphasize hazards and indicate the relative level of severity of the hazard assigned to the GHS hazard class and category. Some lower level hazard categories do not use signal words. Only one signal word corresponding to the class of the most severe hazard should be used on the label. The GHS hazard statement. Standard phrases assigned to the hazard class and category that describe the nature of the hazard. An appropriate statement for each GHS hazard should be included on the label for products possessing more than one hazard. There are some additional elements that are included in the GHS label. GHS precautionary statement. Measures to minimize or prevent adverse effects. There are 4 types of precautionary statements covering prevention, response in case of accidental spillage or exposure, storage, and disposal. The precautionary statement have been linked to each GHS hazard statement and type of hazard. Product identifier. Name or number used for the hazardous product on the label or in the SDS. The GHS label for the substance should include the chemical identity of the substance. For mixtures, the label should include the chemical identities of all ingredients that contribute to hazards. Supply identification. The name, address, and telephone number should be provided on the label. Supplemental information. Non-harmonized information on the container of a hazardous product that is not required or specified under the GHS. Supplemental information may be used to provide further details that does not contradict or cast doubt on the validity of the standardized hazard information. Next, we shall look at hazardous waste. Most chemical waste can be classified as hazardous waste and have the potential to harm people or the environment. They can have carcinogenic, toxic, corrosive, and many other hazardous characteristics and should be treated before it can be disposed of. It doesn't matter where the chemical is used, in the laboratory, in the production flow, or anywhere else. All hazardous waste must be disposed of according to the regulations and standards of the company and the country. First, waste must be collected appropriately using the correct precautions to avoid an accidental release of chemicals to the environment. Appropriate PPEs must also be provided to the workers that handle the waste to protect them from the unwanted exposure. Once the waste is collected, it must be properly labeled according to the type of waste and the hazards associated with it. Warning signs can also be used to indicate waste storage areas so that others will not be exposed to it. A waste inventory should also be kept detailing the types of waste present as well as the amount. This inventory should also be quickly and easily accessible when required. Some waste cannot be released to the environment and must be stored in a safe and secure location. By following these steps, waste can be dealt with appropriately. And that brings us to the end of the presentation. For more information, please do not hesitate to contact us or visit ncpcsrilanka.org. Thank you for your time.